Okay, good morning, good afternoon, and good evening to everyone, wherever you are watching from. Okay, in this video, I'm solving the assignment questions. So we'll be solving it questions by question in this video, and to understand how to go about each and every question in the assignment. So this is distance, the students from distance, DDEOL, that is distance, is it distance education and open learning students. So you had the assignment 1 which was given to you. So we are working on the assignment 1. So we'll be looking at the assignment 1 questions, and then we'll try by all means to see how best we can explain and bring out the basic out of your questions. So I think in this video I'll try to see if I can basically work with question 1 and question 2. So question number 1 is about equations, where we are being taught to solve the following equations. And these were A, where we had 5 power x plus 3 multiplied by 5 power x to give us 5 power 4. So how do we solve this? I believe these are simple questions, and in short these are free marks. So there are a lot of different types of equations. I believe in there are links where I talked about types of equations. So there are different types of equations: quadratic, linear, absolute value, radical equations, and etc, etc. So these are a type of equations which are going to be exponential types of equations. So in short, in most of the cases when we talk about exponential equations, when we look at exponentials, this is a situation where we are trying to solve for x, where x is a power. So there's a difference when I have x squared, and there's a difference if I have 2 power x. Obviously this is a polynomial equation. Obviously maybe we're talking about anything in this format where x is the base and the constant is the power. We'll be looking at this as polynomial equations. Maybe they can fall under linear equation, quadratic equation, cubic equations, and so forth. But when I have a base which is a number and the power is a variable, we are calling this to be exponential equations. So exponentials are coming about when I have a variable which is a power. So when it comes to this case, what are you supposed to remember? Recall the properties of indices in grade, with the ones we are doing in grade something. So recall the properties of indices. That's what you are trying to you'll be able to recall there. So under properties of indices, what am I going to apply here? So the first thing which I am able to observe, I am seeing the same base throughout. It means if I have the same base throughout and different powers, then there are some properties I need to recall. So what properties are there? We have to recall that in a situation whereby I have a power n multiplied by a power m, if I have the same bases multiplying by different powers, I'll maintain the base which is a, but add up the what? The powers. If let's say we are dividing a power m divided by a power m, then we'll just simply take the subtraction of the powers. So this is a property which we are going to recall under indices. So it means I'm going to use this property to solve this type of equation. So we start. So what am I having there? I have 5x plus 3 multiplied by 5 power x to give me a 5 power 4. So these are the same bases on my left side. So I can just maintain my base 5 and sum up the powers. The first power is x plus 3, and the other power is x. So we add plus x. The right hand side I will still maintain it is 5 power 4. So if I sum up the powers, what do I have? I have 5x plus x, that is a 2x, plus a 3 to give me a 5 power 4. So now, what is this? This is an equation. It means the left side is equal to the right side. So if I compare the bases, it's 5 and 5. With an equality in between, it means even the powers should be what? The same, because of equality. So this implies that if this is equals to that, even the powers 2x plus 3 should be equivalent to what? To a 4. Then we can now solve for x here, which should be 2x to be equals to 4 minus a 3 over 2 over 2. These two will go so that I can have my x value to be equals to 4 minus a 3, that's 1 over 2. And we have solved the equation. So the value of x in this equation becomes x is equal to 1 over 2. So the concept which I used here is a concept of indices properties, where when I'm multiplying the same index numbers with the same bases, we just sum up the powers and maintain the base. If we are dividing, we maintain the base and subtract the powers. This property only works with the same base. As simple as that. So this is how we'll solve the first part. The second part is B. I'm going to delete. This is a video. You can pause, you can rewind, you can fast forward. So I'm going to delete. I can put in part B. What is part B saying? Part B is simply saying solve the equation e power 2x over e power 4 plus x, which will give us a 1. The same property of indices will work out. So this e here, don't look at it as a variable. This is a number. In exponential functions, e is taken as to be a number. So e is basically an Euler number, which is approximately 2 point something something. Is it 2.71? Yeah, you should try to confirm when you calculate. I think 2.718, and the count continues. It's a irrational number. The decimal numbers do not have are not terminating, they are continuously moving. So e here is not a variable, e is a number. Just like the way we take pi is also a number, 3.142, and the count continues. The same is happening with e. E is an Euler number, which is approximately 2.718, and the count continues. So e is a number. So the variable we are looking at here is the x. So this is still an exponential function because it's a number power a variable expression. Number power a variable expression. So what am I seeing on my left side? I am seeing division happening. The same, we are going to take division properties of indices. Same bases, we sum up the powers. So the left hand side here, I can maintain to have e power 2x. We subtract the power from the denominator, 4 plus x. You can even see how I've written my expression. I've put the power of the denominator in parentheses, showing that power numerator minus power denominator. This is the power from the denominator. That is why I've put it in brackets. This should give me a 1. So simplifying, okay, this I can use implies that, so that we can try to make things sense. So simplifying my left hand side, this implies that 2x and subtract there, this I'm going to have 2x minus 4 minus 8 after breaking this negative inside the bracket. The right hand side is still maintained, should be equals to a 1. Then continue the simplification. What do I have? I'm now going to have e, these 2x minus x is like times, so 2x minus x, I'm going to have an x minus a 4 to give me a 1. So after simplifying my left hand, I'm going to have that expression. Next, what happens? We still recall some properties under indices. What do I recall? Recall that if I have a power 0, this will always give me a what? A 1. So according to indices properties, anything raised to a power 0, we're going to have a 1. It means that even in this case, if I had e power 0, that is the only time I'm going to have a 1. So if this expression is e power x minus 4 is equals to a 1, what does this imply? It implies that e power x minus 4, which is giving me a 1, will imply that x minus 4 should be equal to a 0. So if x minus 4 is equal to a 0, the power is equal to a 0, this will now be x should be equals to what? A positive 4. And we have solved. So the only way this whole net powers can be 0 is when x is equal to a 4. So e power 4 minus 4, which is 0, e power 0 will give us a 1. So this will be the value of x in this situation. So that's the first question in your assignment. That's the first question in your assignment. You can pause, you can rewind, you can fast forward. That's what we had. So now let's run to question number 2. Let's run to question number 2. So we have our second question there given to us. What are we being told? We are being told that the demand and supply for bags of wheat in central province of Zambia is given by that. So we have the demand function and the supply function given to us. So now I want us to understand two things here. What is a demand function and what is a supply function? What is a demand function and what is a supply function? A demand function, this is just a function. So even before we start solving here, I want us to understand that the demand function, a function that explains a negative relationship. So it explains a negative relationship that exists between the quantity of demand and the prices. So when you look at the demand function, this is a function written which shows a negative relationship between the quantity of demand and the price. So when I'm trying to explain the demand function, I always try to look at it in terms of, always I try to assume as you being the buyer. So if you are the one selling these quantities, bags of rice, so what we are saying, if these two have a negative relationship, is that when you set a cheap price to a bag, you expect a demand, more demand coming to your bags. So you expect more demand coming to the bag. So for example, if I have 20 bags of wheat which I'm selling, I need to expect 20 customers, but these customers will depend on the price I'll set for the bag. I can have 20 customers or I can have more customers if the price is cheaper, but I will have less customers if the price is more. So the higher the price, the less customers I'll have. The lower the price, the more customers I'll have. That is why this is negatively related. And then when you look at the supply function, the supply function here, it's the opposite of the demand function. So with the supply function, what do I have? The supply function here shows a positive relationship. A positive relationship between the quantity of supply and the prices. So in short, what we are saying is that the more the price, the more quantities you will supply when it comes to the supply function. So this one explains the situation where you have the more price, the more quantity of supply. I mean, the more quantities of supplies you're going to supply, you're going to have. So that's the difference between these two guys. That is why in the demand function, the slope is negative, but in the supply function, the slope will always be positive. Slope, I mean the gradient. So this gradient here, 0.5, will always be negative, indicating that between PD and QD, there is a negative relationship. and between PS and QS there is a positive relationship because of this because of this gradient, which is positive. So this is the situation which we have here. So now in this case, or in this question, what are we being told? We are told to calculate the equilibrium price. So now, before you even look at that, I want you to understand it in this manner. So I want you to understand it in this manner. Every time when you look at the demand function, if this was my Cartesian plane, x or y axis, the demand equation, when sketched, it will be in this format. When you sketch, it will pass through at this particular point, which is the 150, which is the price intercept. If this is the price axis and this is the quantity axis, this is what is going to happen. So this curve here will be P equals to 150 minus 0.5 QD if I was to sketch it. By sketching here, just create a table of values of P values and Q values and plot them on your graph. You need to form a straight line which is going to move in that direction. But for the supply function, when you come up with your table of values, you form a straight line which starts from 50, which is the price intercept, and will move in that direction. This will be your supply function, 50 plus 0.7 QS. So when we are looking at this in a graphical form, when sketched, both the demand and the supply function are sketched, we are simply saying that when we are in the market, there will be a point or a time where we can conclude that we are at market equilibrium. We can conclude that we are at market equilibrium. This can only happen when the demand is equal to the supply. So market equilibrium can only happen when the demand is equal to the supply. So from this graph, if this is my demand graph and this is my supply graph, there is a point where they are meeting from. This particular point, there is a Q value and there is a P value. So at this point here is what you are trying to call to be the equilibrium point up. I can call this to be my EO, which is my equilibrium point. So this is where we are calling to be the what? Equilibrium market. So we can only be at equilibrium market when demand is equal to the supply. So at this point, I can find what? QE. QE will be the equilibrium quantity and PE will be the equilibrium price. So that's the base knowledge that you have to understand there. So with this information now, I'm coming back to the question. The question is telling us what? If this is a demand function and this is a supply function, what do I need to solve? I need to give the value of the equilibrium price. So the value of the equilibrium price, it is this P here, which is making the demand to be equal to the supply. So this is what we are going to solve. So since my board is small, I will delete and we start solving now. So when solving for 1, we are simply saying at equilibrium, PD should always be equals to PS. So this implies that PD is equals to 150 minus 0.5 Q, which is equals to the PS, which is 50 plus 0.7 Q. Now, when I equate these two together, what I'm seeing here is the variable Q. It means I'll start by solving for Q first. So if I group like terms together, this will be 150 minus 50 to be equals to 0.7 Q. When this one crosses, becomes plus 0.5 Q. So that's like terms together there, I'm going to have 100 to be equals to 0.5 plus 0.7. I need to have a 1.2. 1.2 Q divided by 1.2 divided by 1.2. The value of Q which according to the equilibrium quantity becomes 100 divided by 1.2. This is approximately 83.333 in that rank. So this is my equilibrium quantity. If they wanted me to have the equilibrium quantity, I could have represented them as the value. But in the case here, they want me to have the equilibrium price. So I will use this to solve for my equilibrium price. Since at equilibrium, PD is equals to PS, I can get any of these two equations, either this one or this one. I need to have the same value of the price. So finding the value of P, can I use this part? Let's hope it will be visible. Finding the value of P means that if I goes to get the demand function, P will be equals to 150 minus 0.5 Q. So upper the Q, put 83.33. So what am I going to have? P will be equals to 150 minus 0.5 multiplied by 83.33. So that when I evaluate, my value of P becomes 150 minus 0.5 multiplied by 83.33333. I should have 41.67. When we subtract from 150, the value of P in this case will be a 108.33. So what we are looking for here, which is our equilibrium price, will be equal to 108.33. That's the equilibrium price. And you are done for question 1. We are okay? So these are the values of the equilibrium quantity and the equilibrium price for question number 2. But there is a second question. There is a second question on what is the same question number 2, where we are being told to explain the effect of introducing a ceiling price or price ceiling of 35 kwacha. So maybe let me just delete my board. I'm sure this is a video. You can pause, you can rewind, you can fast forward. So we have the equilibrium price, we have calculated, that's our value. Now let me delete this part. So from what we have the equilibrium price is equals to 108. What was that? I think what was 108.33. That was the equilibrium price, 108.33 kwacha. So I'm now going back to my sketch. Recall that I said something of this nature. If this was my sketch, where we have this to be P to be equals to 150 minus 0.5 Q, and this is equals to P is equals to 50 plus 0.7 Q. So this will be where my 150 is, this is my 50, this is my 0. So this is my price axis. So if I was to put this, the information which I had solved previously on my graph, what am I having? I am having that equilibrium quantity which we solved was what? What we solved in the equilibrium quantity. We can rewind. We solved the equilibrium quantity to be 83.33. And the equilibrium price was 108. So if I was to replace this on my Cartesian plane, I was simply saying where it is equal here. Obviously the question is not saying to sketch or represent it graphically, but if we were saying represent it graphically, this is what it's going to look like. So where it is meeting here the demand and the supply, that's where I'm having the equilibrium point here. So I'm going to have the equilibrium quantity, which is 83.33, and the equilibrium price, which should be 108.33. So now when we're at equilibrium, this 108 is more like taken as the what's this, the moderate value, or maybe the normal price for both the buyer and the seller not to be affected. At this price, obviously the buyers are willing to get the quantities, and at the same price the sellers are still willing to supply. It's more like a moderate price we can have. So now there are two things which you can now come into play. The two things here, which these are, maybe they can be what we know, what is known as a price ceiling, or they can be what is known as a price floor. There are two things there. So there can be a price ceiling or there can be a price floor which can be imposed in this market. Now, what is the difference between these two guys? When I look at it in terms of the price ceiling, a price ceiling, this is just a maximum legal price set by the authority. So this is a maximum legal price set by the authority. In this case, we can say the government, in that manner. And when you look at the price ceiling, in most cases, price ceiling, this guy is always less than the equilibrium price. A price ceiling, when it is imposed, should always be less than the equilibrium price. It means this favors customers. This favors customers. That's what it means. It means this favors customers. When I look at the price floor is just the minimum legal price. Minimum legal price set by the authority or by the government. I know there are deeper definitions when it comes to maybe if you're doing economics, but this is just trying to look at the theoretical aspect of the mathematics here. So it's a minimum legal price. So this minimum legal price, we are looking at it. In short, this minimum legal price in most cases should be P greater than the equilibrium price. So what is going to be imposed to become the price floor? It should be something more than the equilibrium price. But for the price ceiling, it should be something which is less than the equilibrium price. This one, it favors the suppliers. This one favors the suppliers. So what is happening here? If 108 is my equilibrium price, remember when you talk about the demand, if 108 is the equilibrium price, if we impose the price by the government to say no, don't sell it at 108, but now reduce it to 35 kwacha. We're trying to reduce it to 35 kwacha. So 35 kwacha this time around will become the price ceiling. It is less than the equilibrium price. So any price less than the equilibrium price will become our price ceiling because it will favor the customers. So now what is the effect of this 35 kwacha which has been imposed? We are going to have more customers coming about. So the effect of this, price ceiling here is that we shall have a high demand. We have a high demand. And high demand leads to a shortage. That's the effect you can explain. So in this question, there was a question which was saying explain the effect of introducing a price ceiling in the market. A price ceiling of 35 kwacha. So one of the effect is that a pricing of the 35 kwacha will cause a high demand, which leads to shortage of what? Bags of wheat in this case. It means we have a high demand leading to a shortage, or because there will be what? Less supplies. There is a high demand but there is a low supply. So that's the effect we can explain there. I believe I've explained details in the document which I'll send you. Yeah. So that's question number 1 in this assignment and question number 2. Thank you very much and see you in our next class.